entropy? I think it does. I think as you produce a gas and the gas is able to become more messy and push out kind of on its environment or its surroundings, it is kind of related with work or similar to work. Delta G tells us it's specific to a reaction. It's got to be a reaction or some physical even change. But delta G will tell us how much energy the reaction can offer to be used for work. So it tells us for a reaction how much energy the reaction provides
So that's the G.
as work. Yeah, that's what delta G is. It's called free energy. This equation, that's what the definition of free energy is, but it doesn't really have a good clear meaning because we can't measure how much enthalpy something has. We can measure how much entropy it has, but not enthalpy. So we only can measure enthalpy in terms of a change, and the same thing is true for delta G. We can't measure how much free energy something has inside of it. We can only watch it undergo a reaction and determine how much energy it could give off or take in. This is a very important equation in chemistry. Now that we've seen it once, you'll see delta G terms just about every chapter from now on in this class. It's as important as PV equals nRT, which is a biggie too. So I'm going to move on. I'm going to, please don't get up and leave, but I'm going to do a little tiny baby derivation. We're going to derive something. And we're going to try to answer this question up here.
Do you want to show this down?
No, you don't have to. I'm just showing you why this is. I'm going to come at the very bottom of this page is going to tell you what the bottom line is. In fact, I'll tell you what the bottom line is now, and then I'll show you why that is.
Ooh,
We'll do a reverse derivation.
This and then not do a quiz and a test back to back.
Well, no.
Nothing just happened? Okay. How does delta G relate to spontaneity? Spontaneity means will something be spontaneous or not?
Probably not this. Oh my God, my phone.
The answer is, if delta G is negative, then it will be spontaneous. If delta G is negative, it will be spontaneous.
Why would it have to be negative for it to be spontaneous?
Thank you for asking why. Now I have to do the derivation to show you why.
Wow, thanks a lot.
I was going to do it anyway, though, Colby. So I appreciate you asking. What we'll do is we'll take that free energy equation. Tell you that's a big deal. Divided through by t. So the t is going to disappear from that term, but it's going to show up in this. It's going to be delta G over t equals delta H over t minus delta S of the system. It has lost its t term because we divided through by t. All right. Now I am going ahead and labeling this thing as the system. I don't really need to. If it doesn't say system, we know it just means the system. If I'm talking about the surroundings, I'm going to say surroundings. But, speaking of that, you recognize this thing right here? Delta H over T. You've seen that in the last 18 hours, or 30 minutes in some cases. What is that?
Forgot.
Well, the delta S of the surroundings was negative delta H over T. But if we just... What? Okay. If we call that negative delta S of the surroundings, we can substitute that thing. Yes? Let's do that. Yeah, and maybe you can even see where I'm going with that. Because the delta S of the surroundings is negative delta H over T, that means this. That means that the delta G over T equals the negative delta S of the surroundings minus the delta S of the system. Okay, now I want to do one other thing, and then we're really going to start to see something come into focus. I'm going to give myself a little bit of room and say this. If I get that negative term and that negative term, how about on the right side if I factor out the negative 1? So that doesn't change the left side. Delta G over T equals negative 1 times delta S of surroundings plus delta S of system. What do you see inside the parentheses?
The energy of the universe.
The change in entropy of the universe. Yeah, this is entropy of the change in entropy of the universe. Now, what do you know about the change in entropy of the universe?
The world might answer.
If it's positive, what does that say about the reaction?
Spontaneous.
It's spontaneous. So if this inside of the parentheses is positive, that means it's a spontaneous reaction. The temperature over here is positive. It's got to be in Kelvin. Yes? So what does the sign on delta G have to be for the reaction to be spontaneous? Remember, this term inside the parentheses has to be positive. The temperature is positive. So what would the sign on delta G be if it's spontaneous? It's got to be negative. And that's the answer to your question, Colby. Because the delta S of the universe, this part inside the parentheses, spontaneous means that this term is positive. So a -1 times that positive makes that negative. And since temperature is positive, for a reaction to be spontaneous, delta G must be negative. And I want you to make sure you write that down for yourself. Highlight it, or put a bubble around it, or a cloud around it, something like that. That's probably the most important thing in Chapter 17, is if delta G is negative, the process or the reaction will be spontaneous. Nature tends to favor spontaneous reaction. If you throw an iron hammer out on your front lawn and you let it sit there for a couple of days and it gets cold at night and it's dew and maybe it's got snow on it or whatever, what's going to happen to your iron hammer? It's going to rust. That's right. It's going to oxidize and rust. That happened spontaneously. We didn't need to coerce it. We didn't need to heat it up specially. We just let nature take care of it and it rusts. Nature tends to favor spontaneous reaction. We light some wood on fire, and as long as there's a few pieces of wood in a pile, then that pile of wood is going to burn until the wood is gone, because once we start that reaction, it just goes. And it becomes more, it gives the nature more entropy when it does that.
So nature likes eating itself?
No, and nature tends to, the wood has energy inside of it stored. And when it burns, it gives off that energy. So that's what nature likes, is the release of energy that's stored. Yes, we do have to start the fire, but that's just to break the initial bonds, and once it gets going, it just fuels itself. It kind of provides the energy, the activation energy for itself.
So if it's negative,
If delta G is negative, it's spontaneous. Yep. Okay, so, I'm going to skip that one. This is the last slide. We have a few minutes left in the hour. A spontaneous reaction means delta G is negative, right? If I'm telling you that nature tends to favor spontaneous reactions, what sign on delta H helps delta G to be negative?
A negative.
A negative sign, right. So that means that nature really likes it when matter can get rid of some of its heat. Some of its stored energy, if it can get rid of it as heat, then nature favors that. What sign on delta S favors a negative delta G? Positive, because it's being subtracted. So the more positive delta S is, the more negative delta G is. Jazz?
Oh yeah, it's like the table that just bubble like this.
Yes,
Yeah.
probably so. Yep. You learned this last year, I think.
Yeah.
That it's favorable for a reaction to have a positive delta S and a negative delta H. Now the temperature, keep in mind, is Kelvin. It's always positive. Yeah.
so what if it was like, what if the delta H is positive and then the delta S is negative?
I'm going right there. I have 4 different scenarios. In fact, I'll just uncover all 4 of them at the same time.
Okay.
These are the 4 possibilities for the signs on delta H and delta S. If the delta H is favorable and the delta S is favorable, negative and positive, then for sure delta G has to be negative. I mean, look at it mathematically. If this term is negative and it's subtracting a positive number, delta G will always be negative no matter what the temperature is. So a negative delta H and a positive delta S will make a reaction spontaneous at all temperatures.
Well, even at higher temperature, it's more spontaneous.
Yes, yeah, it would make a more negative delta G. Yep. So really it comes down to just what the sign is on delta G. If delta G is negative, anything, it's a spontaneous reaction. Yeah.
A higher delta G, would that be an increase in spontaneity? Or
What do you mean by higher? More negative?
yeah.
More energy would be given. I remember what delta G tells us. Tells us how much energy is available for doing work. So it just means more work could be done. It probably would have more of an energy given off kind of thing. Now, if both terms are negative, that's a favorable delta H, but an unfavorable delta S if it's negative. So that means we want the delta H term to dominate, and we would want a low temperature. That's what I mean in the second term here. If both delta H and delta S are negative, the delta H is favorable, the delta S is not favorable. So we want that term to be minimized. We need a low temperature. If both are positive, then the delta H doesn't favor the delta G, but the delta S does. So we want the delta S term to be dominant, and therefore we would want a high temperature. Now, you're looking at this probably wondering, well, how low is low? How low do you need it to go, and how high do you need it to go? We're going to do that calculation on Monday. We'll calculate how low does it have to be in order for the reaction to be spontaneous. No, we have to be able to calculate it. It's specific to every reaction.
No, it's always 37 degrees.
And then if both the delta H and delta S are unfavorable, meaning that if that's positive, which is unfavorable, and that's negative, which is unfavorable, then that reaction will not be spontaneous no matter what the temperature is. You can heat it up as much as you want. The reaction is not going to happen spontaneously. Doesn't mean the reaction can't happen. You just have to persuade it. And keep that persuasion on until the reaction's over. And with that, I'm going to quit. Make sure that you do some of the problems for homework over the weekend, the exercise in the book, and the practice test. This is our last weekend before we have our test.
Are you excited for the game? Michigan versus.
Yeah, no. I'm not excited. Yeah. I'm not sure if I'm going to